In the last video, we were introduced to the idea of a z-score and using it to compare two different values that could be on different scales. So in this video, we're going to do a couple more examples with some different contexts to understand how to apply it to more examples. So in this example, we're looking at you competing in the long jump, which is measured in feet, and your friend competed in the mile run, which is measured in minutes. And we'd like to figure out which of you did better for your event. So I've given you some information about the long jump and mile run when it comes to the corresponding mean and standard deviation, as well as what you performed, as well as your friend performed in your corresponding event. So let's actually just talk about these two events first. So let's first talk about the long jump. How do you win the long jump? The further you jump, the better, right? So for the long jump, higher is better, because that is how we would win, is to jump the furthest. Now instead, for your friend, how would they win the mile run? Well, for that, actually, the shorter time or the less time you have, the better. So here, smaller is better. So can we still answer this question? Yes, we still can. We just got to make sure we understood that in one case, higher is better. In one case, smaller is better. So looking through that first, notice looking at you, your jump distance was further than the mean. So you did better than the mean. Your friend's time was under the mean time, which is again a good thing. So they also did better than their mean. But we can still answer this question using our z formula. Recall from the last video that our z formula is the observation minus the mean divided by the standard deviation. So let's do that calculation for you in the long jump. So your long jump distance was 22.48 feet. The mean distance jump was 21.23 feet with a standard deviation of 3.45 feet. This gives you a z-score of positive 0.36. Now recall, why is it positive? Well, it's positive because you jumped further than the mean. More specifically, you were 0.36. Recall our units here are standard deviations. Since you were higher, you were then better than the mean. So you were better than the mean, but not by a lot. I mean, remember, the z-scores have an average of 0, so you're a little bit above the mean. Let's do something similar here for our friend, but keep in mind here that smaller is actually better here. Their run time was 7.61 minutes. The average was 8.65 minutes. And we have a standard deviation of 2.11 minutes. Doing our math here, we get a negative z-score this time of negative 0.49. Now, why was it negative? Well, it was negative because their run time was under the mean. But recall, being under the mean is actually good here, right? So they actually also were better than the mean. So this time, our friend was 0.49 standard deviations better than the mean. Now, a question we might have is, well, where did that negative sign just go? I used that negative when I said that they were better than the mean, right? Because actually, if their z-score here would have been positive, that would have meant they actually did worse than the mean. So So that negative, again, is telling me the direction they were, but that way then I know, did they do better than average or worse than average? So we now know we both did better than the mean. You were 0.36 standard deviations better. Our friend was 0.49 standard deviations better. So who overall did the best? Our friend ended up doing the best. Why? Let's make sure this makes sense when we put it in words. So our friend did better as they were more standard deviations. Better than the mean. All right, but what happens if we're not always looking for being better? What if instead we're trying to figure out who is more unusual? So a different question. So in this one, we wanted to figure out which test score is more unusual. To get a 48 on a Stat 205 exam or an 83 on a Chemistry 115 exam. We're given the Stat 205 exam score mean and standard deviation, as well as the Chemistry 115's mean and standard deviation. But the first thing we want to make sure we actually talk about before we dive into doing some math is, what does it actually mean to be more unusual? So let's first talk about what it means to even be usual. What does usual even mean here? Well, looking at the Stat 205, the mean was a 73. So the most usual observation you could get would be a mean of 70, was to actually get that 73. That would be usual, kind of what we, again, expected to have happen. So usual basically means the mean. So what it means to be unusual is far from the mean. Now I'm going to put far here in quotes because I'm measuring how far you are from the mean. I still have to account for that different standard deviation. So when I say I'm far from the mean, let's go back and remember when we first talked about z-scores. Right, so the z-score, we have our calculation here. But if our observation were to equal the mean, right, the most usual observation I could get, I'm going to get a z-score of 0. So what that means for my example here, being far from the mean, would mean that a z far from 0. Now, I don't have to put the quotes on here for the far because the z is taking into account not just the mean, but also that standard deviation. So as soon as I've done z-scores, I've standardized things. So everything is now in the same units. We have a number of standard deviations away, and we've accounted for means and standard deviations. So what I'm looking for, the more unusual an observation is, the z is going to be far from 0. Now let's see if we can answer our question. So for our Stat 205, our actual observed score was a 48 on the test. The mean is a 73, and the standard deviation is 16. That gives me a z-score of negative 1.56. So what that means here is we were 1.56 standard deviations below the mean, right? That's what that negative sign is telling us, that we performed worse than the mean by 1.56 standard deviations. Now let's look at the Chemistry 115 exam. Here we scored an 83. The mean score was a 61. And the standard deviation was a 12. This gives us a z-score of positive 1.83. So what this means here is that you were 1.83 standard deviations above the mean. But as soon as I said unusual, notice here I didn't say anything about a direction. I don't care if I was really above the mean or below the mean. That really isn't important to me to figure out which score was more unusual. So really, I'm just looking at these two z-scores and figuring out, well, which one then is further from 0? That is the one that is more standard deviations away and thus is more unusual. So this Chemistry 115 exam is more unusual. So our 115 exam score is more unusual as it is more standard deviations away. Because again, I don't care about directions. It's more standard deviations away from the mean. So this gave us a couple more examples to understand how z-scores can be used to answer questions not only now about what score is better, but also about what it would be to be more unusual. And thus we also talked about what it would mean to actually be usual as well. In our next video, we're going to actually begin to introduce the normal distribution, or what we call the bell-shaped curve.